It's time for networking. Okay, so I really want to drive home the way that this flow works. So I did a series of PCAPs at different points throughout this connection. So I ran a PCAP on the client itself. I ran a PCAP on the Palo, which is seeing traffic come in from VPN into the DMZ zone to the steelhead. Traffic coming back because I put a filter in for the source of my IP address of my client, 172.16.0.1. But also traffic that is generated by Steelhead and sent to the server, which is mimicking 172.16.0.1, so you see that traffic as well. And then I performed another PCAP on the server itself so that you could see the connection on that side. So let's start with client. I'm going to have a look here. So I did a filter on the web server IP address 192.168.128.30, and you can see there's barely any information here. And so what happens is this flow ends up transitioning over to port TCP port 7800, which means that the client side and the server side steelhead start talking to each other to basically pass traffic, pass pointers for cached data, and everything that Riverbed does behind the scenes, right? And so you look at this first flow coming from the client to the server. It has this S+, which is basically an indication that there is a Riverbed Probe. So it's TCP option 76. And you see it's reaching out, right? Now these are two different sessions here, two different send packets, right? But it's transmitting the same probe, right? It's trying to figure out if there's a server-side steelhead out there somewhere. And so the server, which actually is a steelhead, responds, and you see this SA++, right? So basically Riverbed Probe query info. So it's listing the type and the version. Now I don't know exactly what that stands for, right? But what does happen a second time is that the server responds fully and provides its IP address and the port, right? And so you see this port 7800 as TCP, and then it identifies the client-side steelhead, which is my IP, my client IP, 172.16.0.1, and the server-side steelhead at 192.168.254.100. So that connection is there, right? So now that it has everything it needs to stand up that TCP port 7800 connection, let me cancel out of here, and we'll flow down a little bit, and we'll see. Here's that connection. It comes up right after the completion of the probe and identifying information for the steelheads so they can learn about each other. And so the flow picks up instead over port 7800, and it is between my client and the server-side steelhead. So that's pretty cool. All right, so next we move on to the Firewall Pcap, right? And so you see the same information, the same flows coming through, right? So you see this probe coming from the client going to the web server, right? And you get the response back. And then you have basically what amounts to a duplication here, another send packet coming through. And so this is the flow actually coming from the server-side steelhead to the web server, right? So it's a separate connection that's being placed there. Because remember when I said that not only does the client do a proxy for cache and data, but also the server-side steelhead. So it's forming a connection with that TCP port 7800 with the client. It's also forming its own 443 connection down to the web server, right? So that's kind of cool. And so I'm actually filtering on 192.168.128.30 so you see the information. And it's just a normal flow with the client hello, TCP or SSL handshake, and the flow of data. So it's kind of cool, right? So I can actually change this and add in 172.16.0.1, and you should see the TCP port 7800 traffic as well. Right, and so here we got it, 7800. Actually, if I go back up a little ways here, we can see more of it. Cool. There's an acknowledgement and a push there. I don't know how that worked out, but anyway, here's the send for standing up the connection, send ACK. So full TCP handshake, all port 7800, right? So this is the connection between the server-side steelhead and the client-side steelhead. Okay, and lastly, I'll take a look at the web server, and I'll put in a filter. Actually, I don't have to worry about it because I'm already here. So you can see the probe coming through, right? Same as usual. Nothing different there. But what you don't see is any more communication, right? So basically that probe will continue to flow on to the destination looking for any steelheads in the path. So we already got a response at the firewall point because of the redirection of traffic using policy-based forwarding down to the server-side steelhead. So you see that. In this case, you don't get a response back, right? So that was the only steelhead in the path. So it's a normal flow, right? So to recap this, so I don't want to spend too much time on it, you have your connection from the client, which does the initial 443 connection, and based on in-path rules that have been built out, we say we want to optimize 443 traffic, right? And so it's going to send a probe. Anytime you browse using TCP 443, or you try to make any connection with 443, right, it's going to send that probe. If it runs into a steelhead along the way, then the steelhead's going to respond. You're going to get the information back, and then you're going to form a peering between the two devices, right? So that works out pretty well. And then on top of that, the server-side steelhead is going to initiate its connection and form a secure connection with the server, wherever it's at. All right, and so you have these decryption points at the server-side steelhead, client-side steelhead, and it's caching data so it can replay it. It's also doing other things like compression, decompression, right? Anything that Riverbed has implemented into this to try to optimize the data, make it go through faster. So that's it. Thanks for watching.